Now, to kick things off, we're pleased to have a webinar special guest, John Hannigan, Director, Global Aftermarket Business with Ford Motor Company and one of the ASE Board of Governors. Thanks for joining us, John.
Thanks, Dave. Hi, everyone. Welcome to this webinar hosted by ASE and the ASE Education Foundation. As Dave said, I'm John Hannigan, an ASE Board of Governors member, but also the Director of Global Aftermarket Business and the Global CEO of the Quick Lane Tire and Auto Centers for the Ford Motor Company. I want to welcome everyone joining us today. We know that you're interested in learning as much as you can to help keep your diagnostic and repair skills sharp, especially as technology changes. That's what today's session is all about. Today's presenter, David Fabricatori, Global EV Hybrid Commodity Manager, Service Engineering Operations for the Ford Motor Company. David will share very valuable insights into electrification at the Ford Motor Company and its impact on service. David, please take it away.
Am I sharing my screen?
Looks good, Dave. We are good to go.
Very good. Hello, everyone. It's a pleasure to be with you. As already been mentioned, my name is David Fabricatori. I work for Ford Motor Company as part of Ford's Customer Service Division. And I'm really looking forward to presenting this topic, which we've entitled Electrification of Ford Motor and its Impact on Service. Before we get into the presentation, I'd like to talk to you a little bit about what I do in the area of the company I work in. So I work in what's called upstream program management and specifically commodity management. And specifically, I look at high voltage batteries. So I'm looking at not only the current battery, but the future batteries that Ford is looking at putting into their electrified products. And my focus is on serviceability. So I'm there representing you to make sure that these high voltage batteries that are being designed by engineering can be serviced in the best way possible. What is the appropriate level to make sure they're safe and to make sure you can get at all the things that you need to do to make it a reliable and accurate repair. So before we get into the kind of the service detail, we wanted to give you a little bit more background on kind of electrification. So the topics we're going to talk about in this presentation are history around electrified vehicles at Ford. So where have we been? Because to really appreciate where we are today, you really need to understand where we've been with electrified vehicles to give you an understanding of really the progress that's been made. Looking at regulations, what is driving electrification around the regulation issues? Looking at the global competition, what is going on not only within our own country, but in other parts of the world, and looking at who the competitors are. Looking at the types of EVs. So when we talk about electrified products, what do we mean by that? What are the types of electrified technologies? And then we want to take a look at where Ford stands today. What is our commitment to electrification and emerging technology? Then take a short look at the 2020 products that are coming out. And then lastly is to look at serviceability. So from the technician perspective, what are we doing at Ford to make sure that we are delivering, what are those special extra things that we have to do, specifically on the battery, these high voltage batteries, to make sure that the repair is done correctly, well, and safely. So let's go to the first topic. So if we look at Ford's more recent history in electrification, we go back to the early 90s. And Ford, like many of our competitors, were sort of learning the regulations, things like the ZEV mandate and Clean Cities initiatives were really pushing the OEMs to invest more of its time and resources of coming out with electric vehicles, electrified vehicles. And so this kind of presents an overview of our early learnings and where we've kind of the progress we've made. And if we look at specifically on the full electric vehicles, so these are vehicles without any engines or just batteries and electric motors. First vehicle we had was the EcoStar. It was a demonstration program. We did about 100 of these vehicles and we logged about 1 million miles. And as we're going through this, what I want you to pay attention to is the type of technology, the type of the cells we use, the type of battery, the weight of the battery, and then the range of the battery. This was a very interesting technology. It was a sodium sulfur, 354 kilograms, which is about 900 pounds. And then we got about just under 100 miles with that. Then we went to Ranger EV, which actually, it started its life, its manufacturing at Edison, at the plant there in New Jersey. And then it was taken off the line, and then it was sent to another facility to basically put all the motors and the batteries into them. The first vehicle ran on lead acid batteries. It had an 870 kilogram pack, which that's about 2,000 pounds almost, and which got us 58 miles. And then later in its life, the whole industry started moving to nickel metal hydride. And if you look at the range increase, and the weight went down fairly substantial from 870 to 485 kilograms. After Ranger, Ford did an interesting thing, and they bought a company out of Norway called Think, and we started producing these small city vehicles. Now, it's a lot of talk about mobility today. This was sort of the point of this car, is about urban mobility, which in some ways was sort of ahead of its time. And that ran on nickel cadmium batteries. Now, that car, granted, is smaller than the Ranger, but it got about the same amount of miles, but only with 240 kilograms, so maybe 500 pounds versus 2,000 pounds. So you can see over time, my batteries are getting smaller, lighter, and more energy per volume. And then lastly on this page is Focus Electric, which this car was built at Michigan Assembly Plant, Wayne, Michigan. It basically was built alongside every other Ford, from the ST to the normal Focus, the base Focus. The interesting thing to look at this one, we first launched it was our first vehicle at Ford Motor Company, launched with lithium-ion batteries, which was the latest tech at the time, latest battery technology. First battery weighed 312 kilograms and went 76 miles, and that was in 2012. In 2017, we increased it to 107 miles. That doesn't sound like a lot, 107 miles, but it's actually a 41% increase in range, but the case didn't change. So there's two battery cases. The case size did not change, but we got more energy and more capacity out of the batteries in the same cases between 2012 and in the last 2 years. And looking at some news information, the cost of lithium-ion batteries actually dropped by 73% between 2010 and 2016. So this slide is just showing a little history and showing you as Ford's learning and other OEMs are learning about the capability and the capacity of electric vehicles, and then what customers want. For instance, on the Focus, it was designed to be a gasoline or a diesel, and so it wasn't designed for big electric vehicle batteries. And so we took a good chunk of the cargo area in the back of the car. We sacrificed that to put the batteries in, because it was not originally designed in. If I take it out now, if I step back and look at hybrid, right? We launched our first hybrid in 2005 with the Escape. The Escape was the first hybrid SUV on the market. It was a 2005 North American Truck of the Year, and the EPA rated it at 70% more efficient than the base Escape. And a fun fact, 90% of all Escape hybrid taxis are still on the road today. So very reliable. That battery was very reliable. It's still running around today. That was a nickel metal hydride pack. And then Gen 2 was launched in 2010 with the Fusion and the Milan and the MKZ. Still a nickel metal hydride pack, but we were able to increase the range, and we're able to make some changes, and we're able to, generation over generation, get cost out, get weight out, and provide the customer with more benefit. But again, these batteries are in the trunk or in the cargo area, so I'm taking cargo volume away from the customer. And then the Gen 3 product, which is the Fusion, C-Max, and MKZ that you see on the road today, that's our first lithium-ion hybrid. We also launched it as a plug-in vehicle with 103 miles per gallon equivalent. And you can see if you look at the city fuel economy, we got better generation after generation. Now, what you don't see on this is really a close-up of the battery, and that's sort of where I wanted to focus next. Is if you look at these pictures from Gen 1 to Gen 3, you can see battery over battery generation, I'm getting smaller and lighter. If you look at the cup in each picture, that's the same size cup, so that kind of gives you a little bit of relevant scale. And then if I go to Gen 4, which is what's coming out in 2020, that battery gets even smaller. And one of the reasons is cell capacity, the benefits of the cell improvements. And then we went to liquid cooled batteries where I can get more dissipation of heat out, so I can get the battery can be smaller. Where previously I was using cabin air cooled. So that first generation Escape, it basically took up the full length and width of the cargo area and the Escape. And from a technician's perspective, I needed to remove it. I needed chains and a cherry picker, an engine crane to get it out. By the time I get to Gen 4, this is the size of about a small suitcase, and really one technician can lift it on their own. So again, generation after generation of improvements in the engineering, the technology that are getting us to where we are today. And so in summary, for Gen 3 products, we launched three hybrids, the Fusion C-Max and MKZ. We had two plug-in vehicles, and keep an eye on this number in your mind. Our range was about 20 to 25 miles of pure electric, and we'll get back to that a little later. And then the Focus Electric, we already talked about that with the two size batteries. And so this a little bit dated, the date on this, but as of April 2019, we sold a little over 700,000 of these electrified products. So now if I transition from sort of the history to kind of regulations is sort of what kicked a lot of this off. It's still a very important piece of this, is what's pushing the industry. And you can see if I look at either European regs or Chinese regs, or US, or even the Middle East, the CO2, which equates to fuel economy, the regulators are continuing to push to get those numbers lower. And electrification is certainly one way of getting there, or helping the companies get there. And China has actually made this public announcement that they want to be the world's leader in electric vehicles. So there's a real big push in China, which is driving some things as well globally around the products that are coming out for electric vehicles. So if I look at just BEV, so full electric, in the next 5 years, this is what the projections are. China will have 243 models on the road with 3.5 million, a little over 3.5 million units. Europe will have 97 models with 2 million units, and the US will have 79 models with just under 500,000 units. I found this Car and Driver article from November of last year, which lists out the new 2020 and future just battery electric vehicles. So on the left, you can see the number. There's about 15 new battery electric vehicles, or model year vehicles that'll be model years, like Tesla, which you probably already. But then there's players like Porsche, Nissan, Audi. You know, these are big names. Jag, that are coming out with performance and electric vehicles. And then if I look on the right, based upon the research, these are the 33 new products, new models that are coming out in the next, this is 2 years. This isn't 5 years, this is 2 years. And the interesting thing about this, in yellow, these are the brands, and the models in yellow are not from the big OEMs. These are from startups or relatively new companies that are getting into the battery electric market. And this is just US that we're looking at here. So everybody knows Tesla, but there's a lot of other companies that are coming in with new products. So if I look at what the regulations want, which is ultimately zero emission tailpipe, and what customers still want is, you know, unlimited driving distance. There isn't an ideal state. There isn't a vehicle or technology that will deliver that today. So companies have to make these decisions based upon their portfolios, to meet the regulations, to meet what customer desires are. And so they have to look at all these different electrified products or technologies to do that. And so you have on the top, on the y-axis, you have your zero tailpipe emissions, and on full battery electrics as well as fuel cell vehicles, they get you there. But they have, you know, the challenges are, you know, range, refueling time, cost and weight. And on the right, the x-axis, you have your driving distance, right? And so to maximize driving distance, you need the plug-ins, and the full hybrids are the ones that get you there. But they have their own challenges because they're not zero emission. They also have challenges because now you have basically an electric powertrain and an internal combustion powertrain on the same vehicle, so you have a lot of complexity. So companies are working through that. And so when we talk about electrification, just to be clear, that there are different categories, and each one of those categories delivers different fuel economies. So your first column goes everyone from what they call micro, which is really your stop-start systems that give you less than 5% and a few digit fuel economies. Your right column, your far right, is your fuel economy, and you go all the way down to your milds and your mediums and your full and your plug-in hybrids, and then you have your full electric at the bottom. And so really what delivers the fuel economy is the technology in the columns in between the type and the percentage, which is stop start, electric, or engine assist, regen braking, electric launch, and electric drive. So all of those enable additional fuel economy, but they obviously they have cost and weight implications to them. So what are we doing at Ford? What's Ford's approach today? So in the past, right, a lot of what moved a lot of the OEMs, including Ford, was the regulations, right? The regulations and competition were sort of moving Ford along this. But we've recognized that really there's a lot of technology that's coming that we really believe is the future, and we really need to embrace that future and use it as a competitive advantage. We have what we call smart vehicles for our smart world, and it's really this diamond of electrification at the top, autonomy on the left, and then connectivity. So electrification is what we've been talking about with these hybrid and plug-in and BEV vehicles. Autonomous is not only the self-driving cars, but it's all that technology that enables that. Things like blind spot detection, adaptive cruise control, lane departure, those kind of technologies that we're enjoying today on our cars today, but they're all enablers to pure autonomy when you think of self-driving cars. And then connectivity is that technology around the relationship, that interconnectivity between the car, the machine, and the person. And then you have the cell phone and the smartphone in between that. We're using our smartphones more and more for so many things today, and the car becomes an extension of that. And so all of these technologies kind of are all interconnected, and we really see this as a benefit to us and our customers, and really the way forward. And so by making this a strategy, we now use these technologies now become incorporated into our designs. It's not just an afterthought, we do it later, we design it one way and then modify it later. We integrate that in from the very beginning. And so what that allows us to do in our Gen 4 products, which are coming out now, is to give the customers really what they want. So for Gen 4 example, the batteries are now under the vehicle. They're not an afterthought in the cargo volume. They're now integrated into the car under the vehicle, where they're out of the way and not encroaching upon the passenger or cargo area. And then powertrains. The powertrains are giving customers what they want in terms of torque and towing and capability. The 2020 Explorer Hybrid is a great example of that. It's got a 3.3 liter V6 with a 10-speed auto, but we also add a 35 kilowatt electric motor, which gives us improved performance, but it also boasts 500 miles per tank. And as I've already mentioned, you can see in the picture, the battery is now under the vehicle where it's out of the way and doesn't encroach on volume interior. So the next two slides kind of talk a little bit about the new product. So this is our hybrid and plug-in product. So in 2020, we're bringing back the Escape, and we're bringing it back not only as a full hybrid, but a plug-in hybrid. And if you remember, I said earlier, remember the EV drive mode on our current Gen 3 products, they were about 2025. Again, generation after generation, we're making improvements. So with this battery that's smaller, lighter, right, we're getting 37 miles of E-range out of that. We already talked about the Explorer, and then we're launching the first two Aviator plugins. The first two Lincoln plugins, one being the Aviator, the other one being the Corsair. Again, the electric propulsion system is actually giving us additional capability, but then delivering 56 mile per gallon equivalent. I mean, to have that kind of capability, but also deliver the equivalent of 56 miles per gallon is pretty extraordinary. And then the Corsair is another winner as well with good performance. And then if we look at the Gen 4 battery electric vehicles, we've already mentioned John already mentioned the Mach-E, I believe. But I want to compare it to the Gen 3 system, right, which again was designed as a gas car, modified to be an electric. It had a top range of 107 miles, motor 143 horsepower, 0 to 60 in just under 10 seconds. The Mach-E now being designed to be to give customers what they want. We've got a range up to 300 miles, motor up to 459 horsepower, and 0 to 60 as low as mid threes. And there are 5 different combinations of motor and batteries. So depending upon what you pick, we'll have some impact on those numbers. But just again, what the customer is looking for. And then in the next couple of years, we'll be launching the new F-150 electric and the new Transit electric. And really in both the electric, the full electric and hybrid and plug-in, there's new vehicles coming out, continuing to come out year after year. So again, talking about that generation after generation improvement, right? Talking about this slide, just trying to illustrate the where we are as far as where customers had complaints about or concerns about, and where we are now. So first one is range, right? Range under 100 miles and 100 miles per charge, right? So today we're up to 300 miles of range on the Mach-E. Time to fuel has always been a concern. We have DC fast charge capability on this vehicle, which can get you as much as 61 miles in 10 minutes of charging. Lack of public fueling has been another challenge, right? We're partnering with Electrify America to expand public charging. I believe VW is also partnering with the same organization, so to continue to expand public charging. Reduce cargo volume, we've already talked about that with the battery underneath. We're going to improve that. No, there's no degradation. Performance, I've heard people say they're slow, but again, 0 to 60 as low as mid threes is fantastic. And then obviously design is subjective. I think the Mach-E looks fantastic. And all the future products will have, designs that people want to buy or want to drive. And then high cost has always been a concern. Mach-E starts in the low 40s. So again, generation after generation improvements in the technology. So now that we've had kind of this little bit of a history lesson, some of the regulations, some of the product information, let's talk a little bit about serviceability, right? Where are we with service? So as much as we've made a lot of improvements, to get 300 miles, it's still a large battery in the Mach-E. So this is the extended range battery. It's approximately 7 feet long by 5 foot wide. It goes basically pinch flange to pinch flange, almost axle to axle, weighs up to 1,400 pounds. So it's a big battery. We like to show that picture on the right. We get a kind of chuckle out of it. Just shows you the size of a person laying on the dunnage that comes in with the battery in it. It is big, just to give you scale. So as we've been developing and working on these new products, especially the Mach-E, we want to make sure that we have in place for our Ford dealers what they need in order for the technicians to be able to service these things, to service these new fantastic products. And so technician training is essential. We are launching all new e-learning at Ford for these products, all new classroom training, and for the very first time, virtual reality technician training. So as part of the classroom training, and you'll have a headset, and I've actually trialed this, a little mini trial where you can literally pick up the tools. You have the headset on, you're actually picking up the tools in the virtual world, and you can actually practice the procedures on a vehicle in the virtual world. It's pretty amazing. It's another enhancement of working on a live vehicle, right? And then the workshop manuals are enhanced as well. And then through this process of training and developing training, I've talking with technicians. I call what I call demystify the box as a result of that, because in the past, a lot of our batteries have been kind of these black boxes, a lot of concern about, oh, it's high voltage, I don't know if I can work on that. But as they're opening the cases up, and we'll show some pictures in a minute, they're finding that they're simple fasteners. They're from an R&R perspective, it's pretty simple to remove the parts, simple connections, and it's clean. There's no oils, there's no lubricants. If you can work on an engine or a transmission, this is far simpler work. But you got to have the right skills and knowledge to be able to be safe. And part of that we've developed new dealer equipment and new special service tools to give the technician the right tools to do the job. And then, as I mentioned early on, I think at the very beginning of the presentation, part of what my team's responsibility is to make sure that as the batteries are being designed by the product development engineering team, that the service team is in there with them and making sure that the needs of the technician are being considered so that the work can be done safely, and that, you know, the things like fasteners are not hidden, that brackets don't have to be taken off to get to another part that's underneath it, right? To make sure that we're simplifying the repairs, making the repairs reasonable for the technician. So so that those are kind of the key pieces in going forward that we've been working on. So looking at some of the more details, as we go from the Gen 3 systems that some of you may be familiar with, if you've worked on CMAX or Fusion or MKZ, to our Gen 4, moving the battery from the cargo area to the under the vehicle has some changes. We're going from a dry environment to a wet environment. We're also on the Gen 3, because it's inside, most of the repairs that you can do, which are shown kind of in that top picture with like the FHEV Gen 3 that's in the like the CMAX, you can do most of those repairs inside the car. You don't have to remove the battery from the car. Because the Gen 4, the batteries are all underneath, every time I repair the battery or take it out, I have to lift the vehicle and then drop the pack to get at it. And because I'm in a wet environment as well, anytime I lift the lid, put the lid back on, the cover, I have to do a leak seal test to make sure that there's no water or debris can get in there. And we'll show you some pictures of how we do that. And then from a design perspective, again, as I mentioned, the serviceable parts were all in sort of a little area on the battery. So part of the battery that had the arrays in them was not serviceable. And then the parts that were serviceable was in this kind of this separate area. Because these batteries, the Gen 4, are now under the pack, I have to make them as shallow as possible because I don't want to affect ground clearance. And so when I open that cover up, everything is there to look at. All those kind of, it's a CAD drawing, but those kind of green and teal parts, those are the arrays. So the arrays, or sometimes they're called modules, consists of the battery cells that are all welded together, and then they're put in a box. So it's all there. It's there. So you need to make sure you know what you're doing. And then the old batteries are air cooled, the new batteries are liquid cooled. And so anytime I remove the battery from the vehicle, I have to disconnect the battery from the cooling system in order to do that. So these are some of the changes that have occurred going from the Gen 3 to the Gen 4. So as I mentioned, we've developed a number of ESSTs, essential special service tools, to make sure that we can do the service procedures safely. We have special vehicle lifting tools, we have special battery lifting tools, and we have special array lifting tools, and then we have a set of different ESSTs for the battery sealing test, which we'll show you in a minute. And then the dealer equipment, dealerships that are going to be Ford certified dealerships also need to have this equipment. So first is a battery lifting table. We've had to work on a battery lifting table that for safety reasons, from the physical safety of the technician, we want to make sure that as these big batteries are coming out, that we have a sturdy platform, that we're not putting the technician in any kind of a physical risk because they are large. So this is a very sturdy table. We also want to make sure that that table is big enough so we don't damage the battery. If the tabletop is too small, we could literally crush the weight of the battery itself, could literally damage the bottom of the battery. So this table is designed for both technician safety, physical safety, to have a sturdy platform, and then for battery safety to make sure we're not damaging the battery if that surface was too small. We need 0.5 psi of pressure to be able to leak seal the pack. We're using a smoke machine, which tends to be commonly available at a lot of dealerships. We're not using the smoke, but we're using the low pressure of that. And then the next two devices are used for array repair, which we'll show you in a minute. And then we need an engine crane that's capable of about 1 ton. So it's important because of the weight that we have at least 1 ton of capability on the crane. So let's go to some pictures. I know everybody wants to see pictures, right? So vehicle lifting on the left. So because this battery is so large, it goes pinch flange to pinch flange, I can't use a pinch flange, which is normally used on a unibody vehicle for vehicle lifting. So the battery side structure is actually strong enough to lift the car for most operations. So replacing tires, brake jobs, almost every repair except for the battery itself, because I obviously can't lift on the battery and remove it. So we're actually going to lift on the pinch on the rocker. We're actually going to lift on the rocker. They've given us some slots in the rocker, and we're going to use these special ESSTs to basically clamp into the rocker. And then you can see where the arrow is on the bottom left, and then we use a 2-pole hoist lift pad right in that area on the bottom of the ESST to lift the vehicle. So once it's up in the air, now I can get the battery out, and there's pictures of the table removing the battery from the vehicle. And this table, I mean, I think this table will be used by dealerships for engine repair and for transmission removal. It's a fantastic table, not only for battery, but for any heavy, large pieces of equipment. So typically when we send the part to the dealership, whether it's an engine, a transmission, an alternator, we don't tell you how to take it out of the dunnage. We don't tell you how to take it out of the box. But because of the size of these batteries, actually in the workshop manual, we're going to tell you how to take it out safely so it's level. We're also going to provide you with some special tools. We have this main lifting bar with spanner bars and straps and eye hooks that is required with a cherry picker and engine crane to do this procedure, because the center of gravity of these batteries is all a little bit different. You can see this battery has sort of 2 arrays on the very back, that hump in the back. So now my center of gravity is further rearward. The smaller battery doesn't have that, so my center of gravity is further forward. My F-150 BEV has a different center of gravity. My Transit battery has a different center of gravity. So we're going to tell you where to put the eye hooks. We're going to tell you where to attach the those spanner bars onto the main bar. And all of this is designed to be very flexible, so that regardless of what battery is in there, we will tell you how to use this equipment. And this equipment is designed to be all forward compatible. So even beyond the products we've announced publicly, this equipment will be used and will be sent to the dealerships for this purpose. So you'll use this equipment to lift the battery out of the dunnage, and then you'll put it onto the table. Table will be moved over to the battery, and we can put it into the be moved over to the vehicle, and then we can use it also to take it out of the vehicle, the battery, on the table, and then use this equipment to take it off the table, put it in the dunnage. So anytime we're doing a swapping of a battery, we'll need this equipment. So we're super excited about the next couple slides. Array replacement. This is something that we've never done at Ford Motor Company. So again, this is where the actual the energy is in the pack. And so we, based upon our warranty data, about the packs that we've replaced in the field, about 75% of those could have been replaced if we could replace the arrays. So starting with the Mach-E and then future BEVs, battery electric vehicles, we will be replacing arrays. And we have special adapters that attach to the arrays, and then they fit onto the lifting bar. What's great about that lifting bar is it's like an I-beam, and basically those arrays, those adapters can fit up to either 1 array, 2 arrays, different lengths of arrays, and then different adapters as well if needed. So it works very well. And so we'll be doing this, and we've had many trials and we'll be doing this starting with the Mach-E. And then I won't be going into a lot of detail, but the middle and the right picture there, these arrays sit on a cold plate. We have to replace the cold plate, which has this interface material that allows for heat transfer. We'll have to be reapplying that interface material using that pneumatic tool. And then we'll have to charge. The picture on the right is a charger. So we'll have to charge the array from the shipping state of charge, which is typically 25% state of charge, to where the rest of the pack is. So if it's at 80%, I got to charge those new arrays from 25 to 80%, and that's what that's for. Picture on the left here just shows you the technicians installing 1 array versus 2, so the flexibility. And then on the picture on the right there now shows you this leak test procedure. So anytime the lid is removed, and most of these lids have a kind of a rope seal, like a rubber gasket type seal, I have to make sure that the pack is leak tested. When the harnesses from the vehicle are removed, the connectors on the pack are not airtight anymore. So these ESSTs, basically the interfacing connector that have been sealed, and then I put low pressure air, and I can monitor it using the gauge on the machine to verify that I have a seal. So I've talked about a lot of information, right? But the most important piece of this is really this last slide. It's the technician. That's the most important piece of this whole discussion, is making sure that as we've been designing all of this, the equipment, the training, the workshop manuals, and even designing the batteries, that they're designed to be safe to the technician, because there is concern about high voltage, right? And so these 4 factors, these 4 decisions, have allowed us to make sure that the certified technician is able to work inside the battery safely. So number 1 is limited access. So first thing the technician will do is to pull DTCs, diagnostic trouble codes. If there's specific DTCs that there's a fault that could expose the technician to high voltage, we're telling the technician just to replace the pack. So things like short to ground, 2 welded contactors, if those DTCs are present, we're not doing any work on the pack, we're just simply replacing it. Number 2 is design. The pack has been designed that every connection where there's high voltage is finger-proofed. I could literally take the cover off and lay on the pack and I would not be exposed to high voltage. Number 3 is procedure. So the workshop manual is being designed to make sure that the procedure that you do will remove all exposure to high voltage. As long as I'm only exposing the post to 1 array at a time, there's no exposure. It's when you're exposing multiple posts to multiple arrays, that's where the potential risk could be. And so as long as we're capping using protective caps and other ways to only expose 1 array at a time, it removes all the risk. And then as I already, where I started from, the service piece is training, right? So new e-learning training, new classroom training, new virtual reality training. And then as far as warranty goes, it has to be technician competency. So as part of the Ford certification process for dealerships, they have to have at least 1 technician go through all the classroom, all the e-learning training. And so it's only that technician or technicians that have gone through that that can work on the pack and be paid under warranty. So I hope this has given you kind of an overview of the history, where we've come, all the progress that we have made coming up to Gen 4, the exciting new products that are coming out and kind of in this electrification space from Ford Motor, and then looking at the unique training, tools and procedures that we've come up with to make sure that the Mach-E, that we can service this fantastic new product and the future battery electric and other electrified products. So thank you very much.
All right, great. Thank you, David. Dan, want to go ahead and get a question or 2 queued up there over in the questions pane? And while you're doing that, I just want to mention to everyone that by now you should be aware that your ASE certifications had been extended due to the COVID situation until December, and that was to give you a little bit of breathing room. But I also want you to know that the test centers are beginning to open up. And for more details on what might be available in your locale, please go to www.ase.com for more details. Dan, over to you.
Thank you, Dave. And David, first one from Thomas, he's across the pond. How about charging in Europe? Is it 230 volts is kind of standard current for household there? Is this vehicle going to be, or this system going to be available in Europe?
Yeah, so there's a team in Europe, part of Ford of Europe, that's working on the whole service launch of this product. But this vehicle I will tell you that this vehicle will be sold in the UK as well as in mainland Europe as well. There will be a number of different charging options available, both in the US and Europe. I don't know the specifics, but I know that there's a number depending upon whether you have it at your home or there's public infrastructure, DC fast charge. So I don't know the details for Europe, but there will be a number of options. And obviously the more capable these chargers are, the faster, the faster the recharge time is.
Then there were some questions Tony and others were asking about the weight of the battery pack.
Yeah, so I think I was back here. I know a lot of information here. So where was it? Here we go. So there's two battery packs. There's the kind of the starting pack. That's about 1,000 pounds, and then the larger of the two, which is the extended range pack, is 1,400 pounds.
Did you mention the weight maybe of an individual array?
That's not information that is well, let's see.
Okay.
No, yeah, that's not really publicly available at this time, but it will be available obviously once we get there.
Awesome, thank you. And then Steve asks, you had mentioned a bit about the shielding and protection under the battery. You asked about crash testing on these models.
Sure, really good question. If you see that this is actually a really good picture for that. So hopefully you can see my cursor. This outer edge of the battery where you see this is all the attachment points to the vehicle, but this whole side area here is designed for crash. It's not only designed for attachment, it's designed for crash. And this is actually the section of the battery that you'll be used anytime you do hoisting or your jack, you use a jack on it to change a tire or something. This vehicle, I don't think they've come out with the official numbers yet as far as what the crash rating will be on the vehicle, but it's gone through all the same crash testing as any other vehicle at Ford. And I know there's very high expectations for this vehicle. It's so I'm assuming, I know that they put a lot of work on the crash, but a lot of systems on board the vehicle, not only the battery, but around the battery to protect it from being damaged.
And then several asked what the voltage is of the entire battery pack, and might you know the individual array voltages as well?
Yeah, so the pack is, I don't have the exact number. I know it's over 300 volts is the total. It's 300 something, I don't know. And then the arrays, one of the things that we try to do is 50 volts is considered high voltage. So as long as you keep it under 50 volts, it's not a high voltage battery. And so these arrays are under 50 volts. I don't know exactly the number, but they are under that 50 volt threshold where high voltage starts.
And then several attendees have asked, are the motors on these AC or DC?
Good question. So they're all AC. AC seems to be the way everybody is going today. So they're actually axle mounted. So the base vehicle is a rear wheel drive. So the base vehicle is rear wheel drive, and then you can get an all wheel drive motor in the front. So both the entry level battery and the larger battery both come with a rear wheel drive variant and an all wheel drive variant. And then there's a GT version that's coming out, which will have a larger all-wheel drive motor. It'll only be available as an all-wheel drive, and it'll have a larger motor in the front. So there's one motor in the front. One motor in the back. It could be no motors in the front, or one motor, and then there's two different motors in the front depending upon what variant you have. But they're all AC. They all have their own inverter controller on them. Yeah, so I think that answers the question.
Okay, and then there was another question about personal protection required when servicing the high voltage battery or the arrays, and what might be required for that.
Okay, that's a good question. So going through these steps that I mentioned to you on the last slide here, working with the engineering team, working with our lawyers, based upon the normal conditions that are present in these steps and the normal replacement of the modules and arrays, there is no PPE required. So we're still working through accidents. If it gets into an accident or the battery is damaged in some way, those conversations are still going on. But for normal technician operation, when they follow these steps, proper training, not opening the pack if any of those DTCs are present. Following the correct procedure, there's no PPE required.
Mark and several others have asked what kind of liquid cooling is being used, and will the battery cooling system need to be serviced? And is there a special bleed procedure if it is?
So it's glycol. It's I think there's two major systems on the vehicle that run on glycol. I believe the battery is one system, and then there's another system that does the motors and the climate system. The glycol system works with, which happens in a lot of electric vehicles, works with what's called a chiller. And the chiller actually uses AC refrigerant, so it chills the chiller, and then the coolant will circulate through the chiller, and as required, will then chill the coolant going through the battery. The coolant on the vehicle, all the coolant on the vehicle has a 200,000 mile life before it has to be changed. There's no normal maintenance at all on the battery at all. So if we have to return the pack, or if you're doing any kind of array replacement because of the way the architecture is, we're basically going to be using shop air just to blow shop air into the battery. So there's two ports on the battery. Let's see if you can see it in one of these pictures. There's two ports on the bottom here, left here. One is an in, one is an out, and you'll basically just blow shop air through one of those kind of cone style funnel things, and then blow the coolant out. And then if it's going to be shipped back, we're going to recommend you take the caps off the battery that was shipped with, and put those on there, and then ship it in the dunnage back. But yeah, so that'll have to be done. So that's for normal. If you're not replacing arrays and not returning the package for things like Beck and Beckham replacements, or if there's a harness or other things, you would just basically cap off. You just cap off remove the coolant lines, and then capture a little bit of coolant that may come out. But we're not requiring you to remove the coolant during many of the repairs. And then you will obviously have to vac and fill the system. You'll have to fill and degas the system when you've replaced the battery, just to make sure you have all the whatever coolant you may have lost during battery repair.
And then there's several folks that would like to know about disconnect procedures for the battery.
Sure. So the first thing you would have to do is there's a manual disconnect on the vehicle. So it's actually located under the hood. There's a low voltage manual disconnect, which basically isolates the power from the battery to the rest of the vehicle. So there's inside of what that's called the BEC, and inside the battery there's contactors. By opening that up, you'll force to open those contactors. When the vehicle is running, those contactors close, which now allows energy to flow from the battery. We want to make sure that during disassembly that there's no way that could happen. So you open up the manual service disconnect, and then you're safe to work on the pack. Again, you verify with the scan tool that you don't have any of those DTCs that are a problem. So once you've manually disconnected the manual service disconnect, you will then use the scan tool to verify that there's no voltage present in the vehicle. So there'll be a process to do that. So you're physically doing it, and then you're doing it with the scan tool to verify that yes, indeed, there is no high voltage present in the vehicle. There are two cooling lines. And then there's three high voltage connections in the front and one in the rear of the battery. And then there's a series of bolts that run along either side of the pack that hold it to the vehicle, and then there's a couple brackets as well, and then it comes out. I mean, the technicians I work with at Ford, they can literally within 20 or 30 minutes have this thing completely taken out of the vehicle. But these are people obviously that have done it a few times.
David, would you have, Mariano and a few others have asked what normal operating battery temperature or the range of the battery temperature might be under normal conditions Would you know that?
I don't know that. I apologize.
Okay, and then also there was a question, two people asked a question about an immersion sensor. Is there a way that the battery monitoring system can determine if the battery is in a position where it's been impacted by water or coolant?
Sure, absolutely. It's a really good question. So, I mean, that's one. Anytime you have liquid in the battery, you're going to get a short to ground. That liquid is going to create a ground. So it has a floating ground. But if you have liquid present, whether it's coolant or so if you have a coolant leak in the pack, or you have water has gotten in through the seal, you're going to get a short to ground, and it's very sensitive. And you're going to get a mill light on the dash. You're going to get a light on the dash, and then the car is going to tell you need to get to you're going to get to the dealership very quickly. So yeah, so it does not tolerate liquid in the battery, and in those cases, the battery is shot, because again, we don't. In those cases, we will not allow a technician to work on it because of the potential. There's a potential of exposure to high voltage. So in those cases, those DTCs would be present, and the vehicle would come in, and we would be replacing the pack at that point.
And then for clarity, several of the attendees have asked about the need in the Gen 4 BEV for a 12-volt battery. Is there one required in those vehicles?
There is, and I mean, 12 volt in most of these systems they're there for a couple reasons. One is key offload. That's its primary function, is key offload, because you do have modules and things like that need to stay awake or need to be powered. And then we also need, in order to close the contactors in the battery to make it functional, we need 12 volts. So the 12 volt battery will initially close the contactors, which then energizes the battery. And now for all other 12 volt power, we use the DC to DC converter. So the DC to DC converts high voltage to low voltage, which then powers all your lighting and all your 12 volt modules and any of your 12 volt accessories are all, when the key is on, they're all powered by the DC to DC. When the key is off, they're kept alive basically by the 12 volt battery.
Okay, and then John sends in, how long can the car or the battery sit without charging, and will the battery be damaged if the battery goes to 0 volts and is allowed to sit?
So, I mean, any battery will degrade over time, but we're talking probably 6 months or more until you really have to worry about it. I mean, it depends upon the state of charge of the battery. If it's a full charge battery, what I've been told is it's 6 months or more before the battery will degrade. I don't know all the details about how long and how low, those kind of things, but under most conditions, you just plug it in, it will work. But as far as how long until you get into a situation where you couldn't potentially charge it, I don't know that.
And then Kevin has a follow-up on the 12-volt battery. Is that a normal battery, or is it more of a deep cycle type of battery? Do you know?
I don't know. My role is on the high voltage battery, so I have an equivalent on the vehicle side who would probably be able to answer that one. I don't know what 12 volts in there.
And then several folks had asked some of the models that are using this. Could you refresh that for us just for a little bit?
Just the slide you wanted?
I think that's the one.
Yeah, so the Mach-E launches in 2021, and then the F-150 has there isn't a lot of public information yet about the F-150 or transit, so I'm not really I can't really speak to it yet. But again, I can tell you on F-150, they know They know the customer base. They know that they can't fool around, right? They need to make sure this is a highly capable truck. And that's the goal, is to make this as capable a truck as you would have on electric as you would have on gasoline or diesel. So that's and it will be a very capable vehicle.
And from Thomas, he asks, do you know if there's a state of charge at which the vehicle will not start like the Toyota does if it goes under 20%?
I don't know the answer to that.
And then I have a comment that came in from Brian, and he wanted to say to you, David, make sure to remind the audience that the Lincoln Aviator GT has more combined torque than a Raptor. And there was a few exclamation points at the end of that.
Well, look at the torque, 630, right? It's pretty amazing. That's a pretty powerful vehicle. 400, almost 500 horsepower at 600 pound-foot of torque. Impressive.
All right, with that, I'm going to pass this over to Dave Kappert. Thank you, David.
Thank you.
All right, Dan, thank you for managing the questions the way you did. Really appreciate it. Thanks, David, for today's insightful presentation. Electrification is the future, so knowing what's coming your way is essential. This webcast was brought to you by ASE and the ASE Education Foundation. For announcements about upcoming sessions, please watch your inbox. On behalf of David Fabricatori, John Hannigan, and Dan Baumhart, I'm Dave Kappert, and this concludes today's webcast. We hope to see you online at another event soon. So long, everyone.